I'm Hayden and this is Gianna, and today we're going to be explaining right triangle trigonometry.
So to begin right triangle trigonometry, you know it, you love it, it's SOHCAHTOA. SOHCAHTOA is easily known as sine, cosine, and tangent, and the letters after it represent what goes on top of each other in the form of ratios. SOHCAHTOA is a form of indirect measurement, which is by definition using another method to find a measurement that cannot be found by actually measuring the length. So, the reciprocals of all of these, which you'll later learn, are called cosecant, secant, and cotangent. Reciprocals, by definition, is a number that can be multiplied with another number to equal 0. So in this case, it's h over O, h over A, and A over O, the opposite of all of these. But that's not really important. So to identify all of these, you identify an x, and an x
is any angle on the triangle that isn't the right angle.
From the adjacent, which is the line going off of it, the hypotenuse, which is always the longest line, and the opposite, which is the line opposite of the angle. Now, another equation that you need to know in right triangle trigonometry is the Pythagorean theorem, which is a squared plus b squared equals c squared, which is only applicable to right triangles. So from this is derived a certain set of numbers that are always perfect. So if these two are the shorter lengths and you need to find the hypotenuse, this is always bigger. And you can explain that by plugging that into the Pythagorean theorem. So in this case, 3 to the fourth plus 4 to the second equals 5 to the second. So in short, that's 9 plus 16 equals 25, which if you add it out is correct. So to do a sample problem, what we're going to do is this. And what we want to find is cosecant, which as you can see here is h over O. And so tangent, by definition, is opposite over adjacent, so what we want to find is the hypotenuse. So to solve this, you want to plug it into a right triangle. You want to identify an A, and you want to find the lines. So Hayden, if you could, you can do the opposite, which is 5, so that will go right here. And then the adjacent, which is 30. Now to solve for the hypotenuse, you plug that into the Pythagorean theorem. I don't think that reduces.
Yeah.
So that goes here. And now you have enough information to find the cosecant. So you take the hypotenuse, which is 34, right cosecant of A. Is equal to the hypotenuse over the opposite. Wait, that's not the opposite. That's the opposite. And there you've applied right triangle trigonometry. There's so much more you can do with this, but I think this is where we're going to stop today. I hope you have a good one. My name's Gianna. This is Hayden, signing off. Okay.
What's it called?
Just broke your pen. I'm not getting there yet. Let's back in. We're finding tangent of A. We're finding tangent of A.
Hey, do you know what you're doing?
James.